Hello and welcome back. In our previous videos, we have discussed the linear sequence, quadratic sequence, and cubic sequence. One type of sequences is left, and that is exponential or geometric sequence. In this video, we are going to discuss this in detail. So let us start it. So basically, a sequence where the next term of the sequence is obtained by multiplying the previous term with a certain number is known as an exponential sequence or a geometric sequence. And the nth term formula for an exponential sequence is given by a multiplied to r to the power n minus 1, where a is the first term of the sequence and r is the common ratio or the number being multiplied over here. So if we see a sequence over here with the terms 1, 3, 9, 27 and so on. So I see if I multiply 1 with 3, it becomes the second term. When we multiply 3 to the 3, it becomes the third term. And we multiply 9 with the 3, it becomes the third term. So we can see the term to term rule for this sequence is multiply with a 3. So it is an exponential sequence. Now, first we are to write the next two terms of the sequence, and for that we will multiply 27 with 3, that becomes 81. So that is the fifth term of the sequence, and the sixth term of sequence will be 81 times 3, and that becomes 243. So these are the next two terms of the sequence. Then it said find the nth term formula for the sequence. As we know that it is an exponential sequence, and nth term formula for an exponential sequence is a multiplied to r to the power n minus 1. Here we can see that a is 1 because a was the first term of the sequence and r was the common ratio or the number being multiplied. So it is 3 over here. So r is 3. Now we replace the values in the formula and that shall give us the nth term relation for this sequence. So Tn equals 1 multiplied to 3 to the power n minus 1, and because being multiplied with 1 doesn't change anything, so it shall become 3 to the power n minus 1. That is the nth term formula for the sequence given, and we can also verify it by substituting the value of n for any term. Like if I replace 5 over here, it shall become 3 to the power 5 minus 1. It is 3 to the power 4, and that is 81, and we can see the fifth term of the sequence is 81. So that is how we find the nth term formula for the sequence. Then it said also find the 10th term of the sequence. So in order to find the 10th term of the sequence, we will replace n with 10. So the T10 or 10th term shall become 3 to the power 10 minus 1, which is 3 to the power 9, and if we expand it, it shall become 19,683. So that is the 10th term of this sequence. So this is how we deal with the exponential sequence. Let us discuss another example of an exponential sequence. So the question over here states find the nth term formulas for the two sequences given. The sequence in part A have terms 2, 8, 32, 128 and so on, while the sequence in part B is 18, 6, 2, 2 upon 3 and so on. So we can see the first sequence, the sequence in part A is an increasing sequence, while the second sequence is a decreasing sequence. And in order to figure out the type of sequence, first determine the term to term rule for the sequence. In A part, if I can see that when we multiply 2 to the 4, it becomes 8, and when we multiply 8 to the 4, the same term, it becomes 32. And again, in order to get 128, we multiply 32 with 4. So the term to term rule over here is multiply by 4. So it is an exponential sequence or a geometric sequence, and the term multiplied over here is r. So if it is a geometric sequence, the nth term formula for this shall become Tn equals a multiplied to r to the power n minus 1, where a is the first term and r is the common ratio, which is 4 over here. In a part, the value of a is 2 and the r is 4 to the power n minus 1, and when we simplify it, it shall become 2 multiplied to 4 can also be written as 2 square, and it shall become 2 to the power 2 into n minus 1, and when we simplify it, as the two have same base, it shall become 2 to the power 1 plus 2n minus 2, and the most simplest form of this relation is tn equals 2 to the power 2n minus 1. So this is the formula for the nth term of sequence given in part A. Now we come to the B part, where the sequence is a decreasing sequence. When we see the terms are 18, 6, 2, 2 upon 3. So basically we are dividing it with the 3. So by dividing with 3 mean we are multiplying it with 1 upon 3. When we multiply 18 with 1 upon 3, it becomes 6, and when we multiply 6 with 1 upon 3, it becomes 2, and same number is multiplied with 2 to get the next term. So the term to term rule over here is multiply with 1 upon 3, and as the term to term rule is multiplication, it is also an exponential sequence, and the common ratio over here is 1 upon 3. So the nth term formulas for this sequence shall become, the first term over here is 18, 18 multiplied to 1 upon 3 to the power n minus 1. Now this can also be simplified to a little extent, and because 18 can be written as 2 multiplied to 9, and because it is 1 upon 3 to the power n minus 1, and when we take the reciprocal of base, it becomes 3, but the power symbol shall change, and that becomes 3 to the power 1 minus n. So again we can simplify it. It becomes 2 multiplied to 9 can be written as 3 square, and because the base are same, so we shall add the powers 2 plus 1 minus n, and the final result for the nth term formula becomes 2 multiplied to the 3 to the power 3 minus n, or minus n plus 3. So that is the nth term formula for the sequence given in part B. So this is how we deal with the nth term of exponential sequence, and then we can figure out any of the term of given sequence.